All right. Okay, we are moving on to the next thing. This is a very long slideshow. We are not going to do it in one day. We're going to do it in chunks so that our brains can understand all of it. Yes, chunky. Anyway, we talked about the different parts of the electron cloud in the last slideshow. The thing we need to talk about now is how do the electrons fill up the cloud. There's actually a pattern for how the electrons arrange themselves, or you might say how the electrons configure themselves in the electron cloud. And so we're going to talk about how they do that. And then we're also going to need to learn the system for writing it down. There's a system that chemists have come up with to communicate where the electrons are. Okay, so quick recap. We have energy levels, yes? Those energy levels can be broken up into what? Sublevels or subshells. Those are labeled SPDF, and they have different, well, and then those subshells then contain orbitals, okay, increasing number of orbitals. Depending on what subshell you're in, you get a different number of orbitals. And then those orbitals have different shapes, right? But they all hold the same number of electrons, right? One orbital holds how many electrons? Two electrons, okay? Characteristic shape contain 2 electrons. Great, so we got that, cool. Now we need to talk about how the electrons fill the cloud, okay? Looks a little something like this. S, what do I have on the second energy level? I have a 2s, what else do I have? 2p. Anything else? Anything else here? No? What about third energy level? 3s, 3p, 3d, thank you Daniel. What about the fourth energy level? 4s, 4p, 4d, 4f. What you just told me are the names of the subshells, okay? So I have these subshells, and the orbitals in that subshell have the same name, okay? 4s, 4p, 4d, 4f. Okay, great. So that's kind of our visual representation, okay? So we're going to fill these up now, okay? So as we go down the periodic table, obviously we are getting more electrons, right? If we assume that all of the atoms we're dealing with are neutral, neutral meaning the number of electrons equals the number of protons, right? Positive and negative cancel. Okay, this is kind of just introductory stuff. You don't necessarily have to write all this down unless you really want to, but we're getting more electrons, okay? So as we go through the different elements, we need to put electrons in the cloud, and they're going to arrange themselves, okay? And they're going to go higher and higher in energy as we go through the periodic table. Okay, so we're going to talk about the system for keeping track of it. Okay, this is kind of an introductory slide, but you can summarize that however you want. Okay, we need a system for tracking where the electrons are because they fill it in a certain pattern. Okay, so what is the pattern that electrons use to fill up the orbitals? Okay, so this is where electron configurations comes into play. Okay, so what an electron configuration is, it's just how the electrons are arranged in the atom. Okay, where are they, so to speak? Or which orbitals are they filling and which ones are they not filling? Oh, sorry, I'll go back. Didn't mean to do that. Okay, so the way I'm going to write down an electron configuration is I'm going to take the subshells that have electrons in them, and then I'm going to write a little superscript next to it with the number of electrons that are in that subshell. Okay, so I'm going to show you some examples of what this looks like. Okay, so I'm going to skip that because I just said that. Okay, so let's say I have some electrons in a 1s subshell. Okay. Side question, how many orbitals would be in an s subshell? 1. So how many electrons can I have max in that subshell? Up to 2. It could be empty, but it could have 0, 1, or 2 electrons. So the way I would write that down, oops, I'm going to do that with examples. The way I would write that down is I would have 1s to label the subshell, and if it has 1 electron in it, I put a 1 as a superscript to say how many electrons are in this subshell. Okay, so this is not, there's no math here. It just looks like an exponent. It's just it's a label to tell me how many electrons are there. If I have 2 electrons, I put a 2. That means I have 2 electrons occupying the 1s subshell, which we obviously know means it's a 1s orbital, and there's only one orbital there because we know how subshells work. If it's empty, you just don't write it. Okay, so there's no like 0. It's kind of redundant. If it's not filled, you just don't write it. Okay, so we've got that. What if we had some electrons in a 3p subshell? So how many orbitals do I have in a p subshell? One person knows. How many orbitals can I have here, or do I have here available? Besides Daniel. He showed me on his hand. So I'll take an answer even if it's wrong. I just need you guys to talk to me.
Pick a number one.
Lily's about to say it. 3! Yes! Okay, I have 3 orbitals in this subshell, which means I can have how many electrons maximum? 6. Awesome. Great teamwork back there. I like it. Okay, so depending on how many electrons I have here, I just used a different subscript to indicate that. So, okay, so if I have 1 electron in there, I put a 1 superscript. If there's 2, I put a 2. All the way up to 6. So these are different ways that it could be written. Okay, so I'm just showing you some examples of what this looks like. Hey, Mr. Bess. Okay, so obviously I would not have all of these written at the same time. It's depending on which situation I'm talking about. This is how I would label where the electrons are, okay? So now, let's take it up a level, okay? So this is just if there's one subshell, but if we have lots of electrons, they're going to be filling lots of subshells. So how would I put electrons in multiple subshells? Well, you just take these subshells and you just write them next to each other. And we're just going to have a string of the subshells that contain electrons, okay? So let's say I have 3 electrons. This configuration is telling me where they are in the electron cloud. So this means I have a 1s subshell, and it has 2 electrons, because it's labeled right there. And I can't fit any more electrons in there, right, because there's only 1 orbital. So the 3rd electron has to go somewhere else. It goes into another subshell. So it's going to be in the 2s subshell. It's right there. Right? So you can tell how many electrons you have by adding up the subscripts. Yes? Yeah, makes perfect sense. Okay. Another example, what if I had 8 electrons? Okay, those would have to go slotted into different subshells. That could look something like this. Okay, I could fit 2 in my 1s subshell, I could fit 2 in the 2s, and then the other 4 could go in the 2p. Okay, so in total I have 8 electrons. And in order to indicate which subshells have them, you just write them in a string, no spaces at all. It just all goes in one big string of letters and numbers. Okay, but I'm just labeling which subshells have electrons, and then superscript tells me how many electrons are in each subshell. Cool? Makes sense so far? So this is how we write them. Okay? You could probably imagine, so like, if I gave you an element with like 80 electrons, you could imagine these get pretty gnarly, right? Pretty long. So then once we learn how to do these, then we have to learn the next system of how to abbreviate them, but that'll be next week. Okay, but just a little sneak preview of what's to come, okay? So now we have to figure out, okay, interesting thing is, assuming all of our elements are neutral, which we're gonna get past that later, but for now we're gonna assume they're all neutral. Every element has a different number of electrons, right? Because if I add a proton, and I'm assuming that it's a neutral atom, I have to add an electron too. So what we realize is that every element has its own electron configuration. The pattern of all the numbers and letters that tell me where the electrons are. Okay? Now, instead of me writing down every electron configuration for every element, what I can just show you is the pattern of how the electrons fill up the subshells, and then you can figure it out from there. Okay, so I'm not going to show you like, here's all the electron configuration for all the elements. I'm just going to tell you the pattern, and then you will have the tools to figure it out for yourself. Okay, so a nice thing about nature is that it follows a pattern. It's not random. Okay, so we just need to learn the pattern. We good? Can I keep going? Okay. So if I remember the next slide, there are 3 rules. Yes. There are 3 rules, and by rules I mean like laws, right? Patterns that tell us how the electrons fill the orbitals or the subshells. We're only going to talk about the first pattern today. Okay, the first one is called the Aufbau principle. It's named after a guy named Aufbau. Okay, simple observation. Electrons will fill the orbitals or the subshells from low energy to high energy in that order. So the subshells are the orbitals that are the lowest energy. Those are the ones that get filled up first, and then once it's full, then you have to go to the next one, fill that one up, then you go to the next one, fill that up with electrons until you've used all your electrons. But they fill themselves from low energy to high energy. Okay, we will talk about 2 other rules next week. Okay, so these are coming, but we're not going to talk about them yet because I don't want to do too much all at once. Okay, so we're just going to talk about this first principle, and then that's pretty much it for today. I don't know how you're doing notes. If you're going to come back and fill this in later, just they're all 1 sentence. If you're wondering how much space to leave, or if you just want to rewrite it when we come back to it, however you want to do it, it's fine.
So what element are we stopping in for the test?
36. The quiz tomorrow is 21 through 36. I'll post a Kahoot if I haven't already, just to do that.
I'm just trying to make this.
So is this the last quiz?
Now, we're going to go, I'm going to try to get to 86, so we're just going to add a row each time. Okay, we need to be familiar with most of the periodic table. So this quiz has 16 elements, and then the next one will be 18, and the next one will be, well, 17. So, we're leveling up as we go. Okay, cool with this? Okay, so we're filling up from low energy to high energy. So then that raises the question, well, which orbitals are the lowest energy and which are the highest energy? What order should I fill them up? Okay, well, we might think, well, we already know about energy levels. I just do the first energy level, and I do the second energy level, and then I got my third energy level, fourth energy level. You just go in order, right? Makes perfect sense? That is wrong. This is not actually the order that we fill them up. Even though the energy levels are labeled here, it's more complex than that, okay? So we have to look at what the actual order is, okay? Here is a diagram that shows us the order that the subshells actually go in, okay? So at the bottom is low energy, and it goes up to high energy. Okay, let's take a look at what we have here, okay? So here's my first energy level, is this red line, and there's 1 subshell, which is the 1s. Here's my second energy level. Notice how there's 2 subshells here, right? The 2s and the 2p. Okay, great, so they're going in order, fine. But notice what's happening is if the second energy level has a range of energy. The 2s is slightly lower energy than the 2p. Even though they're on the same energy level, if we go to that finer degree of detail, the S is a little bit lower energy than the 2p. So the entire energy level actually has a range of energy. Okay, minimum energy, maximum energy. If I go to the third energy level here, now I have 3 subshells, right? I have a 3s, a 3p, and a 3d. And the S is slightly at lower energy than the p, and the p is slightly lower energy than the 3d. But notice what happens here. In the fourth energy level, I have S, P, D, F. See the green ones here? But notice what's happening. There's overlap. So the principal energy levels overlap with each other so that the subshells don't necessarily just go in numerical order. So the first and second energy levels are separate from each other, but the third energy level and the fourth energy level overlap. So the 4s is actually lower energy than 3d. And then you can kind of see some other things up here. 5s is lower energy than 4d. Okay, so this is the actual order that we have to fill the subshells with the electrons. So electrons will fill the 1s first, then they fill up this one, they fill up this one, and they fill it in order of low to high energy. But the subshells don't necessarily go in numerical order like we would have guessed. Okay, and this is just what experiments have shown us. Okay, so it's a little more complex. Okay, so if I were to write this out, okay, if I just wrote these all in order, okay, this is the order that the subshells get filled in. Okay, now before you write this all down, stop, don't write it down. Okay, this looks like a big mess, right? 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, right? It's a big mess, okay? There's an easier way to keep track of this, okay? Let me show you how you can know what order they actually go in. If you write it in a table form like this, where I have my first energy level, second, third, fourth, fifth, sixth, seventh, and then I just write the subshells on each energy level. Okay, so these are all the subshells on the periodic table. I guess plus a few extra actually. If I fill them up diagonally, or if I go through this table diagonally this way, and so forth, notice that if I follow these arrows diagonally, it's the exact same order as this. It's a beautiful system. It's so nice. Okay, so first is 1s. Okay, great. Then I go to the next one. 2s is right here. And then I go to the next diagonal. 2p. And 3s. And I go to the next arrow. 3p. Down to 4s. Next one, 3d here. 4p. 5s. It goes in order, so you just follow it diagonally. Okay, here's another chart that has the arrows already kind of written on there. So this chart is what I recommend using in order to remember what order the electrons go in the subshells. I'll give you a second to finish writing that. This is much nicer than just having to memorize that big string of subshells. That'd be a pain. Make sense so far? Okay with this? So what this chart is telling me is the order of energy. The top here is the lowest energy subshell, and then if I follow these diagonal arrows, these subshells are ordered from low energy to high energy. Okay, so this is the order that I have to fill the subshells in.
So how come we don't know all the
Say what?
How come the ones don't know all the names?
What do you mean? Wait, did you have a question or? No, you're good? Okay, sorry. Yes, and my chart here has a few extra subshells than this. If you were to add up all the electrons right here and you fill up the 7p, in total that's 118 electrons. So that's the end of the periodic table. So I have a few extras here, but there's no elements that actually go to this subshells. So it ends with 7p. Okay, so that's our pattern. Cool? Can I go to the next slide, or we still need it? Okay. Interesting thing. So this actually is really cool, because there's another way you can figure out the order. Well, do I have that next? Yes, okay. There's actually a really cool thing, and this actually explains, this chart explains why the periodic table is the shape that it is. Okay, this is going to blow your mind. You're all going to be like, oh my gosh, Mr. Floyd, this is amazing. Okay, promise. Okay, just hold on. And actually, I don't even use this chart because the periodic table secretly is this chart. Okay, let's unpack this a little bit. Okay, I'm going to start with my 1s subshell. How many electrons can go in that subshell total? 2, because there's one orbital. How many elements are on the first row of the periodic table? 2, yeah? Ah, okay, interesting. Next subshell, how many electrons could go in the 2s? Total? 2, yes? How many elements right here in this block? Interesting, okay. After 2s, I go to the next arrow, go to 2p. How many electrons total could I fit in this p subshell? Not 4. 6. 3 orbitals, 2 each is 6. How many elements are right here? Interesting. Okay, after the 2 becomes another s, so that's another 2 electrons, yes? 2. Okay. After the 3s, I'm going to go to 3p. 6 elements for 6 more electrons. Interesting. 4s. 2 right here. Go to the next one, 3d. How many electrons can I fit in a d subshell total? 5 orbitals times 2 each is 10, right? How many elements are right here? 10, yes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, so this little middle box here is representing that 3D subshell. And then after D is 4P, which is 1, 2, 3, 4, 5, 6. So the periodic table is actually shaped to match this pattern, okay? And I think I have another periodic table that I can put on top. It follows the same pattern, okay? So if I just look at the periodic table and follow these blocks in order, 3p, 4s, 3d, 4p, 5s, 4d, just follow it down the rows, it matches this chart. So really, you don't even need this chart. You can use it if you want, but if you know how to interpret the periodic table, it's the same thing. Whoa, crazy. This is amazing, Mr. Floyd. Okay, so the periodic table is shaped the way it is because it's illustrating this pattern right here. So all of these elements here are in pairs of 2 for a reason. They're S subshells. Okay, these are in blocks of 10 for a reason because that's the D block, P, and then we have rows of 14 down here because in an F subshell you can have up to 14 electrons. That's why there's 14 elements in those 2 rows. Okay. What subshell comes before 4F? Because they're kind of chopped out. So where does this go in relation to the rest of this? What comes before the 4F? 6S, 4F, right? So the 4F goes right here, right? So it goes in that order, and then after 7S, you have 5F. Okay? 7S, 5F. Okay. Again, the periodic table matches that chart. Yeah? Okay. So there are 2 ways that you can remember the pattern. You can just use this chart, or you can just look at the periodic table and know how to read it. Okay? How about we do some practice, and then we're done. Sound good? Okay, so group 2, P block, D block, F block. Cool, said that. Okay, let's do some practice, okay? So I have some elements. Let's write down their electron configurations. We're going to assume that all of these elements are neutral. The number of protons equals the number of electrons. So I should know how many electrons I'm dealing with, okay? Hydrogen, how many electrons? It's less than 2, and it's not 0. 1, okay? I'm going to write an electron configuration, and I need to indicate where that electron is. I have this whole electron cloud, but where is it? Well, if we remember the Aufbau principle, it starts with the lowest energy subshell, which is that, right? 1s. So if I'm going to write the electron configuration, I'm going to put 1s, 1. And I put a superscript of 1 to show that there's 1 electron in that subshell. Okay? Then we go to helium. How many electrons now? 2. Can they both go in the 1s subshell? Is there room for a second electron? Yeah, so we'll put it in there. So we're going to fill up the subshell before we go to a new one. So helium is going to be 1s2 because I can fit 2 electrons in that s subshell. Okay? For lithium, I have 3 electrons. Can I fit 3 electrons in a 1s subshell? No. So what I'm going to do is I'm going to fill up the 1s2, but then that 3rd electron has to go in the next one. The next subshell is 2s. So I'm going to put 2 electrons here, and then the 3rd electron is going to go in the 2s. So my electron configuration is going to look like that. 1s2, 2s1. Okay, I'm showing where the electrons are. And it's like saying what hotel room they're staying in the electron hotel that we talked about a couple days ago. Okay? See if you can finish out this column. Okay? See if you can do the next 3 elements on your own. Beryllium has 4 electrons. 2 of them can go in the 1s. 2 of them can go in the 2s, so I should have 1s2, 2s2. Boron has 5 electrons. The 1s is full and the 2s is full, so that 5th electron has to go in the next subshell, which would be the 2p. So boron ends with 2p1. 1s2, 2s2, 2p1. Carbon has another electron. Now I have 6 electrons. Can I fit more electrons in the 2p still? Yeah, so I'll put that 6th one there. 1s2, 2s2, 2p2. Let's keep going. Let's go to sodium. See if you can go all the way to sodium. We got to keep in mind, I can fit up to 6 electrons in this p subshell. Okay, so we're going to just keep adding to the 2p until it's full. Okay, so nitrogen is going to end with 2p3. Oxygen, 2p4 at the end. All the way until neon, where we fill up that p subshell. So with neon, all the subshells are full. Yeah, and then the question is, if I have an 11th electron, I need to put it in the next subshell, so what comes after 2p? 3s. So then that 11th electron goes in the 3s. Okay, we just fill them up until all the electrons have a place to stay, so to speak. Are we okay so far? Does this pattern make sense? Okay, let me just throw another one, and then I think this is the last thing. Okay? Let's do titanium. See if you can do titanium. which is on our quiz tomorrow. Wow, so perfect. So titanium is number 22. We gotta put 22 electrons in the right subshells. What subshell am I ending with for titanium? Should end with 3D. Should be that. Okay, so 2 electrons go here, 2 more go here, and the next 6 go in the P, 2 more go in the 3S, 6 more go to the 3P, 2 more can fit here. That's 20 electrons total. And then the last 2 go in the 3D. So it should look a little something like that. Do it right? Awesome. Okay. Cool. Okay, I think that's all I got. I think there's one other slide, but I don't think I want to talk about it yet. We'll talk about that later. Ooh, electron configuration simulator. Do I want to give you homework tonight? Votes for no homework? Alright, we'll do a quiz in the worksheet tomorrow in class. Awesome.
Why do I sleep like this? This hurts.
Yes, you already asked about that. There you go. Oh, I gotta turn this off.